In this lesson, we will continue to study the surface drainage facilities of subgrades. Have you ever seen steeply sloped ditches with water not leaving the bottom of the channel on highways in steep side slopes or deep ditch areas? These are chutes. They usually serve to divert water flow in a short distance through channels, reducing hydraulic head and thereby preventing erosion. Chutes are typically set up on high embankment side slopes, high cutting slopes, at the junction of cuttings and high embankments, and in side ditches on reverse curves. They are used to discharge water from side and interception channels. Hence, the structure of chutes should be robust, stable, and durable. Next, I will show you interception channels in different locations. First, we see the chute in the high embankment side slope field sections. This is the junction of the cutting and the high embankment. By setting up a chute here, water from the cutting section's interception channel is collected and drained to the cutting side ditch. Chutes slow down the flow of water to prevent erosion of the subgrade. The diagram on the right shows a chute on the cutting side slope. The longitudinal slope of the chute should generally not exceed 1 to 2, and its main dimensions are determined by hydraulic calculations. The wall thickness of a mortar rubble rapid flow channel is 0.3 to 0.4 meters, and for a concrete rapid flow channel, it is 0.2 to 0.3 meters. Usually, the thickness of the channel bottom is between 0.3 to 0.4 meters. It's worth noting that if the chute is long, it should be constructed in sections, each not exceeding 5 to 10 meters in length, with expansion joints provided and the joints filled with waterproof material. When water needs to cross the subgrade while being constrained by design elevation, pipelines or channels can be used, either under the subgrade or overhead. The former known as inverted siphons and the latter as flumes. The Daxing-Anling-Qingling inverted siphon in Gansu, China, is the longest in Asia, with a total length of 524.8 meters, consisting of double rows of steel pipes with a diameter of 2.65 meters, making it the largest steel inverted siphon in the country, as shown in the diagram on the right. Seeing these typical cases closely related to us, I wonder if it enhances the student's sense of national pride. Although the Daxing-Anling-Qingling inverted siphon is quite old, there are still many design and construction methods worth learning from it. Inverted siphons and flumes are equivalent to culverts and water bridges, respectively. Both are special structures for surface drainage of subgrades and are mostly used in conjunction with agricultural water management needs. Inverted siphons are often set up when the subgrade crosses an existing channel, and the channel's water level is higher than the design elevation of the subgrade, making it impossible to set up a culvert under normal conditions. In this case, using an inverted siphon is one of the feasible solutions. When there is a significant height difference between the original waterway and the subgrade design, such as when the terrain on both sides of the subgrade is favorable, or when it is necessary, simple bridges can be set up to span over the subgrade with water troughs or pipelines as flumes to facilitate water flow on both sides of the subgrade. Evaporation pond refers to water collection pool set up at regular intervals on both sides of the highways in areas with dry climates and difficult drainage, allowing the water from side ditches to accumulate and evaporate. When the outlet of a subgrade drainage ditch is located in a water quality sensitive area, and the discharged wastewater does not meet the standards specified in the Integrated Wastewater Discharge Standards, an oil-water separator can be installed. For situations where water collected in subgrades cannot flow naturally, drainage pump stations can be set up. This method is more suitable for urban road rainwater treatment. By learning about the surface drainage facilities of subgrades, we understand that there are many types, and everyone should learn to distinguish their differences, laying a solid foundation for future blueprint reading and construction work. Thank you.